Okay, welcome to 6.2, more on solving log equations. Last time we looked at how to solve if they had a like base or if they were in logarithmic form to change them to exponential form. So log base 10 is known as a common logarithm and is often written as log of x. So if you don't see a base listed, then it's understood to be base 10. So if you see me give you a problem that says base 10 and you drop the base 10, I am fine with that. So find the exact value of log base 10 of 5. So I'm going to go ahead and put that in exponential form, remembering that it is understood to be a base of 10 right down there. So that means my base is 10. I'm trying to find the exponent that would give me a 10 to the 5th power. Oh look, my bases are the same. So what does that tell me my answer is? It is just 5 because my bases are the same. So when I get down here to number 2, log base 100, again, my base is 10. So I'm going to have 10 to what power equals 100? Well, I'm going to rewrite them so they have the same base. 100 is 10 squared. So my bases are equal, so my exponent is a 10. So on the next one, base of 10 equals a 0.0001. Well, that is less than the number 1, which means it is an exponent. I want to write it with the base of 10, and since it's less than 1, that means my exponent would be negative. And to get my 0 to be at the end of the problem, I'm going to move it 4 places. So my exponent of what I'm trying to find here would be a -4. Section 2, given an exponential equation, rewrite each side of the equation using exponents with like bases. Now when you get to your test, it's going to have these all mixed up and just say solve. So you have to make sure you really understand each way. So if you get lost one way, you can try a different way. So on this one, I want to try to get them written so they are the same base. The bigger the base I go for, the better. So I recognize that 64 is 4 to the 3rd, and then I raise it to the x power. Can I get 256 to be a bunch of 4s as well? So let's see. I know that 64 times 3 times, so I'm going to try 64 times 6, which is 16. 24 and 1 makes. So this one over here is 4 to the 4th. So what does that mean? 3x equals 4. Oh, so what does that make x? 4/3. So that's one reason about knowing about the bases, getting them to be the same. When we did them on 6.1, they always were a lot nicer to solve. You kind of saw the relationship. This is a 4/3. I don't think I could have found a 4/3 without knowing how to solve this problem. So number 5, 1/3, I'm going to rewrite that as 3 to the -1, and then I have it raised to the 2x. So how can I rewrite 81 with a base of 3? That would be 3 to the 4th power. 9 times 9 is 81. 9s are 3 times 3 times 3 times 3, which would be 3 to the 4th. So again, my exponents, 3 to the -2x equals 3 to the 4th. Since bases are the same, I can set the exponents equal and solve, so x is a -2. That way I was able to flip from having a fraction to a non-fraction answer, and I would be 2 times 2 would be 4, and 3 to the 4th gave me the 81. Section, we're going to use the property that if m equals n, I can't get the bases to be the same. They're two different numbers. Then what I do is I log both of them, and the best base to choose is base 10 because that's what our calculator chooses, and that's what our base numbering system is. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would take all 10 fingers to do those. That's 10 digits. So I can't make 30 on example 6 become a same base. 3 to no power will give you 30. 3 times 10, but that's not an exponent. Okay, so log base 3 of x equals 30. There's no way to rewrite 30 using a base of 3, so I can't do the last method of getting like bases. So instead I will log both sides. So I get the log of base 10, 3 to the x equals log base 10 of 30. I'm going to stop reading log base 10 because if I don't say a base, that's understood to be 10. So now what did my rule say from the last section? It says you pull that x out in front. So x log of 3 equals log of 30. And now to solve and get x by itself, I will divide both sides by log of 30 divided by log of 3. Log base 10 of 30 is a decimal number. Log base 10 of 3 is another decimal answer. You can't reduce them, so you can't say, oh, 3 goes into 30 10 times. You also cannot cancel out those words log either. So your final answer is log of 30 divided by log of 3. That would be the exact answer. Now, if my math lab asks you for a decimal, pick up your calculator, any scientific calculator, type in log of 30 divided by log of 3. And then you should get your correct decimal. Your decimal should be 3.096 if I take it out the 3 places. So notice up here we said leave answers as exact answers. Number 7 is slightly different for a few reasons. Number 1, the exponent's not by itself. So how do I get the exponent by itself? Correct, I add 4 to both sides. So 10 to the x equals 38. Again, I can't get 10 and 38 to have the same base. So I'm going to log both sides. Log of 10 to the x equals log of 38. And then I'm going to pull my exponent out in front. X equals log base 10. X log of 10 equals log of 38. And again, I divide both sides by the log of 10. Did you just say something? I think I heard you say that log base 10 of 10 is special. What's special about log base 10 of 10 on the bottom? Remember, if your base and your argument are the same, that's equal to the number 1. And we don't need to ever show our dividing by 1. So my final answer this time is simply log base 38 because log base 10 of 10 is 1. All right, number 8, 5x plus 14 equals 21. Again, I want to get the exponent part by itself, so I'm going to subtract 14. 21 minus 14 is 7. Again, 5 and 7 can't have a common base, so I'm going to log both sides. So log of 5 to the x equals log of 7. Now, if you wanted to, you could put log base 8 of 5 to the x equals log base 8 of 7. That just complicates things. So we're used to being in base 10, so the best choice is to put it into base 10. Next semester we'll learn about natural logs, and that's also another good choice. I'll pull my exponent out in front, so x log of 5 equals log of 7. Undo my multiplication by dividing. So my exact answer, log base 7 divided by log of 5. And again, I can't do any reducing. Those are two different decimal numbers, and it's not log base 5 of 5, it's log base 10 of 5. So it does not just become a nice 1. My final answer is log of 7 divided by log of 5. Okay, so our next way of solving equations, if some but not all the terms of an equation have a log expression, we rewrite the equation so that all the log expressions are on one side of the equation and the term without the log expression is on the other side of the equation. And then we condense the side that has the word logs to a single logarithm using our log properties. And then we convert to exponential form to solve. So on example 9, we have log of 3x plus 1 equals 2. So there's the word log on one side and a number on the other. What is my base that is understood to be on number 9? My base is understood to be the base of 10. So now I'm going to rewrite that in exponential form. 10 raised to the second equals the 3x plus 1 argument. So that was showing you those little arrows if you like to use those little arrows. What is 10 squared? It's 100. Now it's just a basic linear equation to solve. Subtract the 1 to get 99. and divide by 3. So 99 divided by 3 is 33. The quick check that you want to make sure that you do is that you have a positive argument. So if you plug in your x value to this 3x plus 1 right here, will it give you a positive number? 3 times 33 is 99, plus 1 is 100. It's a positive number. So that's a quick, easy check to see if you did it right. Number 10, log base 2 of x plus log base 2 of x minus 3 equals 2. I've got all the logs already on one side. I have multiple logs, though I have 2 of them. I want a single log, so they are the same. So I'm going to rewrite the left side, log base 2. What does addition lead me to? Correct, to multiplication. So I have x times x minus 3, and my left side will stay just the number 2. So now that I've got a single logarithm on one side and a number on the other, or it could be a variable, I'm going to rewrite in exponential form. My base is 2, my exponent is 2, and that's going to equal the x times the x minus 3. I'm going to go ahead and distribute that x. I could have done it before rewriting in exponential form. Oh, I have a quadratic now. What is 2 squared? 2 squared is 4. So how do we solve a quadratic? We move everything to one side. I can't convince some of you, quit moving your x squared, making it negative. Leave it on the side that keeps it positive. And then instead of moving your x squared, move your 4 to the other side. Some of you are having trouble trying to factor with those negative x squareds. I don't blame you. I wouldn't factor with them either. So now I'm going to factor. Can you give me 2 numbers that multiply to a negative 4? So since my first term is x squared, I know it has to be x and x. My last term has to multiply to 4. Do you think I should use a 1 and a 4, or should I use a 2 and a 2? I don't have to consider the first term since it's a 1, so which combination is going to give me a 3 if I'm subtracting? How about the 1 and the 4? I want the 3 to be negative, so I need the 4 to be negative and the 1 to be positive. Now, just to make sure I did it correctly, I'm going to mentally check it. The first term, x times x is x squared. X times 1 is 1x. Negative 4 times x is negative 4x. Yes, that gives me that middle term of negative 3x. And finally, my last term of negative 4 and 1 multiply to give me a negative 4. And now what do I do with each of those? I set them equal to 0. So x is going to be a 4, or x is going to be a negative 1. Let's just kind of check the 4. I don't have much room for checking, so I'm going to go up here and write out the check for you to see it. Some of you do not understand that when you check, you go to the original equation. Do not change anything. Do not act like you're solving. You are evaluating one side and then the other side to see if they match. So I have log base 2 of 4 plus log base 2 of 4 minus 3. Now what I really want to know, is that positive? Yes. Is that positive? Yes. So I'm going to hope I did my factoring correct and everything else correct. Because it's hard for me to go through actually evaluating log base 2 of 4 and log base 2 of 4 minus 3. I don't think I'll have time for that. So what I really want to do is make sure that you know that both of those are positives. Now let me check the other answer, which was a negative 1. Oh, right there, it doesn't check. Remember, your arguments cannot be negative. So even though it would check on the other side, 4 minus a negative 1 would be a 5, which is positive. The first one does not check. So that's the quick kind of checks you want to do, so that when you're giving me your answer to this problem, you're only giving me the answer of 4, because the negative 1 does not check. Over here, my 33 checked, and my 4 did not. And my 4 did, but my negative 1 does not. So you always have to be careful. Sometimes both of them will check, sometimes neither, sometimes one. If nothing checks, it's no solution. Okay, number 11, again, I got all the logs on one side. So log base 2, what does subtraction lead us to? division, x plus 5 over x minus 2 equals 3. Oh, this is why we had to do rationals 2 units ago in order to, before we could do our logs, because that's a rational equation. So now I'm going to rewrite an exponential form. 2 to the third equals x plus 5 over x minus 2. If you would rather write x plus 5 over x minus 2 equals 2 to the third, that's perfectly fine also, if you like your x's on one side. So 2 to the third is 8, so I'll take care of my exponents. Now, how do I solve this? Remember, we multiply both sides by the common denominator, which would be x minus 2. So 8x minus 16, those cancel, leave me with x plus 5. I'll move my x to the side of the 8. 8 minus 1 is 7x. And then I'll move my 16 to the other side. 16 plus 5 is 21. And 21 divided by 7 is 3. So my quick check, is 3 plus 5 positive? Yes. Is 3 minus 2 also positive? Yes. So my answer of 3 would be correct, as long as I didn't do any other mistakes mathematically. Okay, number 12, log base 8 of 2 equals 1 minus log base 8 of 4x squared. Oh, all my logs are not on one side, so I need to move them to one side. I'm going to move the one that's negative because when I move it, it would turn into a positive. So I'm going to leave my log base 8 of 2 on this side, and then I'm going to add the log base 8 of 4x squared to that side, and that's going to equal 1. So now I have the logs on one side, number on the other, and then I'm going to make sure that I combine my logs. So I have addition that leads to multiplication, so 2 times 4x squared. I'm going to continue to simplify. 2 times 4 is 8x squared equals 1. Now I'm going to go to logarithmic form. 8 to the first equals 8x squared. 8 to the first is just 8, so I'm going to divide both sides by 8, and I get x squared equals 1. How do I solve that? I take the square root of both sides. Whenever I take the square root, remember it's plus or minus 1. Please never leave us a square root of 1. Square root of 1 is not simplified. Square root of 1 is 1. And if I had to square root both sides, then it's plus or minus 1. So, will they both work this time? Remember last time on problem 10, the negative didn't work. Let's see, will it work this time? So basically where I'm plugging it into is right there. So if I take 4 times 1 squared, yes, that's a positive number. That's 4. What if I took 4 times a negative 1 squared? Well, negative 1 squared is 1 times 4 is still a positive number. So this time, both the positive 1 and the negative 1 will check. So I can have both answers because my order of operations had me squaring and they both turn out to be positive. So that concludes section 6.2. Remember, if you're struggling, please come in and get some help. We would love to help you with being successful on this next test.